For chapter who?
For chapter 17.
I did not check the bin.
Okay.
So they were handed in, yeah. Okay. I think I'm recording already. No, we got to finish this. Okay. So we're on page 32 of your lovely booklet. Super exciting. We're going to do some transformations. I know you're super excited. Okay. So, sorry, I moved that and I didn't need to. I'm going to zoom in again. Oh no, that's as zoomy as I get. So here's your basic graph. Here's your basic graph. And here's the equation with all the transformations applied. So you guys have done chapter 1 over and over and over again. So this should be very straightforward. What? We're gonna just, you know what? We're just gonna describe the transformations. Let's get rid of the parameters. Yeah.
So is it only going to be a reason to put that, like x minus 1, 2? Or like, can you do like different factors, like x minus 1, x minus 1,
No.
No?
You would just have like x to the exponent 4 or x to the exponent 5. That would be your...
Like multiple times.
Right.
Okay.
Yeah. Yes. Yes. Okay. So let's talk about this. So that's going to be your A value, your B value, your C value, and your D value. Word. Okay, so what's happening with that negative 2? Well, what's happening with that negative? Reflection in the x. Okay, what's happening with the 2? It's what kind of stretch? Vertical.
If you're actually putting it in, do you do stretches and then reflections?
Reflections and stretches are both multiplied, so it doesn't matter what order you do them in. Okay?
But it does when it comes to shifts.
Right, you stretch, you do all your multiplying first, then you do your adds or subtracts. Let's talk about the B. Nice. Yep. Okay. So I think the easiest way to do it is do the table of values for my original graph. So the y equals x cubed. So let's do just some nice ones. Let's do -1, 0, and 1. Let's just throw the 2's out the window. What's -1 cubed? -1. Good job, everybody. What's 0 cubed? 0. And what is 1 cubed? 1. I'm proud of you guys. But it's a cubed function, right? So where is my x-intercept? No, that's 0, but there's a drag. Oh no, so I'm not doing my transformations yet.
Okay.
Can we graph this just for funsies? Because at this point, you're going to have a drag. Because what's my x-intercept here? What's my x-intercept of this graph? When y is 0, what's x? X is 0. And how many x's do I have? 3. So it's a multiplicity of 3. So you have a drag at that point. Because if you just go ahead and graph these points, I just want a real 10. Having a hard time. So 1, 2, 3, 4, 5.
Wait, can you tell us the drag by just looking at the cube?
Yes and no. So if we were to solve for the x-intercepts of this, so we have y equals x cubed. If I were to solve for the factors, the zeros, the x-intercepts, whatever, the roots, we're going to put in a 0 here. And we're going to cube root it, right? If you were to expand that, would you guys agree that that's expanded? So there would be 3 x-intercepts all at the exact same place. So x equals 0 has a multiplicity of 3. So that's why there's a drag. Well, it's related to your x-intercepts, but I know that this basic graph will have x-intercepts at 0 because there's no like shifts or anything on it. So I knew from the exponent it was going to be that. But here on this one, it's a cube. It's not going to be at the same place. Okay? It will still have a drag. Okay, sorry, having a hard time answering questions, trying to do increments, trying to find a pen. 4 comes after 3, just in case you're wondering. You guys are all graphing this, right? So if I go ahead and graph that original function, I'm going to graph that in green. I got 0, 0. I got -1 and 1. And I got 1 and 1. If you do a linear function and cut that once, you'll be incorrect because you need to have the drag on it. The drag. Hey, let's just live on the edge. What would be 2 cubed? 8. So at 2, you would be way off the graph up here somewhere, right? So when I come through here, I'm going to get close to the x-axis. I'm going to drag through, and I'm going to go down. So that looks very different than just a straight cut. Does that make sense to everybody? Like the difference between... Yeah, kind of looks... That's exactly what it looks like. It looks like a tan graph. Okay, so that's our basic one. That was graphed in green. So now let's do our transformations. And we've decided that we'd like to do all of our transformations on the x first. Okay. So what am I doing to my x's? So -1, and what's happening? 1/4, and then add 1. So we're at a -1/4, and then we're going to add 1, so we're at 3/4. Okay? Math. 0. 1. Okay, good job. Yeah, okay. I was a little late to the show for that one. 1/4 plus 1. 5/4, or 1 1/4, whatever makes the most sense to you. Okay, so let's talk about our y's now. -2 and add 3. So this is going to become +2 plus 3 is, hopefully it's 5. So this one's going to be 3. 1 times -2 is -2. -2 plus 3 is 1. So where does your drag move to? So you have to have a drag here. The drag, you can't get rid of the drag. The drag still happens because that is the graph. So, but now you need to know where that drag transforms to. So 1, 3, 3/4, and 5, and 1 1/4. Okay, so again, you can't just make it a linear graph. That won't be correct. You got to do the drag through that point. And we anticipated that, right? Like, because it was a reflection in the x-axis. So it was up, now it's going to be down. Like, that side's going to flip down. So that's not terrible. That's just chapter 1. No, not really. Just making sure you're paying attention to your multiplicity, because if you just graphed those 3 points on the graph, it looks an awful lot like a linear function. Right? Okay, Bill is preparing to make an ice sculpture. Good job, Bill. He has a block of ice that's 3 feet wide by 4 feet high by 5 feet long. Bill wants to reduce the size of the block by removing the same amount from each of the 3 dimensions. He wants to reduce the volume of the ice block to 24 cubic feet. Got it? I love it. I love it. So 3 feet wide, 4 feet high, 5 feet long. So Bill wants to cut off the same amount from each of the 3 dimensions. Do we know what that is? Hey, what's the volume of this thing right now? What's the volume? 60. How do you know that? So if left as it is now, it has a volume of 60 cubic feet. So Bill wants to take the same amount off each dimension, and he wants to reduce the volume to 24. So if we don't know what that dimension is, that's going to be our goal to solve that dimension for poor Bill. We've got to figure this out for the guy. So if we don't know what it is right now, we're going to represent the unknown with x. Beautiful. So the height now becomes 4 minus that dimension, because we want to take it off, so it's going to be a subtract, right? And then the width would be 3, and we're going to minus the exact same amount from that. And then the length would be 5 minus the exact same amount. And when multiplied together, that gives me the volume, so that's going to be 24. Got it? And you're just like, oh, well, it's going to be 4, 3, and 5. But it's not, because this isn't equal to 0. You can't factor it yet until you do it. So we're going to multiply. Go back to grade 10. So how we multiply many factors, start with 2. Can we do that? So then we're going to multiply. So I did 12 times 5 gives me 60. 12 times negative x gives me negative 12x. Now moving on to the 4. So that's going to be a negative 20x minus 4x squared. Oh, plus 4x squared. Thank you for catching that. And then negative 3. So we're going to have negative 3x. Ooh, I could have tightened that up and made that 7. I don't know why I didn't. Whatever. Whatever. You and your good math. Me and my bad math. Plus 3x squared. And then plus 5x squared minus x cubed equals 24. Okay, we're going to combine like terms. Okay, I see you're super excited about this. What? What? Okay, so I only have one of those, so I'm going to deal with so I've got a negative x cubed. Oh, negative 37 is the x's? Shouldn't it be 47? It's okay. You had good math before. Okay, let's do our x squareds. Are we good with x squareds? So 4x squared, 3x squared, 5x squared, 12x squared, and we said negative 47 for our x's, and then plus 60 equals 24. So obviously what we want to do is we want to solve for whatever the x's are, so we've got to get it equal to 0. Why don't we move everything to the right-hand side so that x cubed becomes positive? Lily, are you having a hard time seeing that? You need a boost. So we're going to have 0 equals x cubed minus 12x squared plus 47x minus 36. Oh, I put 2 equals zeros. Sorry. What did you say, sir? Okay. Okay, so we've modeled a situation, we've done that. How much should he remove? Now we're going to factor. But we're going to do synthetic division and things like that. Okay? Which one? Positive 1? So, hold on. This is how they know. So this is going to be 1. This is going to be negative 12. Positive 47. Negative 36. So these two add up to negative 48. 47 plus 1 is also 48. So negatives cancel out the positives. So x equals 1. Well, that's not a factor. That's a solution. What's the factor? X minus 1. Yes. Do we have all of them represented here?
So we're going to get multiple answers that we can use?
We're going to find out in a second.
Well, like, imagine some of them are going to be negative and they'll be positive.
So if the x was negative, how could we remove a negative dimension?
Yes.
Right? So we would reject that.
So all of them are going to be negative except for it's not contradictory.
Can we factor that? So if we can't factor it, like 36 is going to be 9 and 4. 6 and 6. 3 and 12. Can we? Does 3 and 4 work? Basil and his magical calculator. So this one, if we look at it, it's an x squared. So we've got 2 ways to attack it. We can factor it, like grade 10, or we can quadratic formula it, like grade 11. So let's quadratic formula it. What's 36 times 4? It's 144.
I was going to say 4. It's 40. It's 40 times 4 is there. 20. 1/3 is 4.
Anybody see a problem?
One of them is going to be imaginary.
Can I deal with that?
No.
So this is unfactorable.
Well, there's, wow.
So what's my only answer? So how much am I taking off? One what?
1 foot.
This doesn't really seem that much less. Then again, because it's a 3 feet wide by 4 feet. 1/3. It's a bit of ice.
It's a bit of ice. It's a bit of ice, Bill. It's a bit of ice. Okay, one last word problem.
Oh, there's more.
Wait, there's more. Nobody likes these questions. You did a ton of them in grade 11, and they're probably some of my favorite things to do.
Oh, these are systems. Well, not really systems. But
Not really systems, but
it's like numbers and not like.
but it's like a good feeling thing altogether.
When you sound like real life, that's just numbers.
Okay. Easy peasy. 3 consecutive integers have a product of negative 210.
So x equals 1
Yes.
equals 210.
Negative 210. Yeah.
Oh, negative, sorry.
Yeah. Okay, so this is where people struggle. What does consecutive mean? In a row, right? Like it means 1, 2, 3, 4. Like you don't skip any, it's in a row. So if we were to have an example, like it'd be 9, 10, 11 are consecutive numbers. If we don't know what the first number is, what are we going to call it? X. If we don't know what the second number is, how do I get from 9 to 10? Plus 1. So if I didn't know what the first one was, it's going to be X plus 1. How do I get from 9 to 11? And it says that their product is negative 210. So obviously I'm multiplying them. Obviously. Duh. We're going to do the exact same thing we did in the other question.
Is this a test one?
Yep.
No. You want to grab it?
Kind of.
No, don't put this in the
See what I did there? I multiplied those two. Are you suggesting I enjoy graphing? I do.
Not the factor's 210.
Mm-hmm. So that is the writing the model, like what we just did there. So I'm just asking you to get that equation. Okay. I'm going to tell you that 1 doesn't work, positive or negative.
Number 2.
It should be a negative number.
Oh my god.
And how do we know it should be a negative number? Because it needs to equal a negative number, right? So we should be dealing with negative. So working a little bit smarter, we know that we're dealing with a negative number. I will tell you it's not 1, and it is not 2. It's not 1, it's not negative 1, it's not negative 2. Nope, you guys are going to find it. Guys, you need to get a calculator out and start calculating, because I'm going to sit here until you guys are done. I'm going to get on my phone.
Let's just leave.
No, it's okay. If you want to do it the smart way, put it into decimals, find the x values in decimals. There you go.
There you go.
That was so many words and I understood none of that.
Put it in decimals, find the x-intercepts.
No.
X equals negative 7.
Oh my god. Don't spoil it, Cameron.
How is it Nika? Your mom?
Huh?
There's going to be a throwdown.
Like 100%.
Wow. Yeah. What's the negative 7? I guess that. So you didn't
Okay, now that you know that, can you do the rest of it?
Yeah.
Go.
No.
Go.
I was trying to find it organically, but that's okay.
What? Yes. I think what you said, I think I know what you said, and I think the answer is yes. No, this will be there will be a word problem on the test.
Okay, but not this.
Maybe. Why is this bad?
Because it would take forever to find the factor.
You found the factor in like less than 3 minutes.
Because of photo math. We don't get photo math.
It is a good point.
I'm not going to give you a factor that you're going to take 20 minutes to find.
You never know.
There you go.
Why do you use it?
So,
Wait, am I using it wrong?
what?
7 words.
Yes, it does.
Can I do it wrong?
What?
Mine's 7 words.
Negative 7 works.
Okay, move on. I'll figure it out.
Okay. Okay, can we factor that?
No.
Are you sure? You looked at it on Desmos?
On the back. So there's only 7.
So,
Only -7.
only -7. Here's the thing though, sometimes there will be multiple answers and you'll have 2 sets, which is fun. So if we know that x is equal to -7, what's my second number? -6, okay? People want to add to it and they go to -8 and that would be incorrect. So the next one would be -6. The third one would be -5. Because you go back up to this and you're adding 1 and adding 2. Okay? So this would be the 3 consecutive integers. Done. Do we have time to do 10?
No.
I feel like we do.